we're covering the equilibrium of rigid bodies and the concept of statical determinacy, a critical topic from the statics portion of the FE civil exam. For any rigid body to be in equilibrium in a two-dimensional plane, it must satisfy three fundamental equations, which you can find in the statics section of your NCEES FE reference handbook. These are: the sum of all horizontal forces equals 0, the sum of all vertical forces equals 0, and the sum of moments about any point equals 0. While 6 equations exist for three-dimensional problems, the FE civil exam heavily favors 2D systems. The key to solving these problems is to accurately identify all the unknown forces, which are the support reactions. A roller support provides one unknown reaction, which is always perpendicular to the surface it rests on. A pin or hinged support provides two unknown reactions, typically a horizontal and a vertical component. A fixed support, like a pole cemented into the ground, resists all movement and thus has three unknowns: a horizontal force, a vertical force, and a moment. Once you've drawn your free body diagram and counted the total number of unknown reactions, you can determine the nature of the structure. This is called statical determinacy. It's a simple comparison between the number of unknown reactions, let's call it R, and the number of available equilibrium equations, which is 3 for 2D systems. If R equals 3, the structure is statically determinate, meaning you can find all the unknown forces using only the 3 equilibrium equations. If R is greater than 3, the structure is statically indeterminate. There are more unknowns than available statics equations, and you'd need more advanced methods to solve it. If R is less than 3, the structure is unstable and will not be in equilibrium under general loading. On the exam, you'll be asked to either solve for the reactions of a determinate structure or to classify a structure. Let's consider a common exam problem: a simple beam on a pin support at point A and a roller support at point B. The unknowns are the two reactions at the pin, X and A, and the one at the roller, BY, for a total of 3 unknowns. Since we have 3 equations, the beam is statically determinate. Here is the number 1 exam trap and the most efficient solution strategy. Always sum the moments about the pin support first. By summing moments at point A, the forces X and A pass through that point and thus create no moment, dropping them from the equation. This allows you to solve directly for the reaction BY in a single step. Students who start with summing forces in the X or Y direction will be left with a system of 2 equations and 2 unknowns, wasting valuable time. Another common trick is a roller support on an inclined surface. Remember, the reaction force is perpendicular to the inclined surface, not vertical. You must resolve this force into its horizontal and vertical components. To quickly classify a 2D structure, use this mental shortcut. R equals 3 is D. R is more than 3 is I. R is less than 3 is U prime. That's reactions equal to 3 is determinate. Reactions greater than 3 is indeterminate. And reactions less than 3 is unstable. For free practice questions, AI-powered explanations, and more exam prep tools, visit openexamprep.com. That's openexamprep, all one word.com.